Here we are again then. So this is lesson 6, gravitational potential energy from the P1 energy topic. Make sure you've got something to write with, something to write on, and you will need a calculator for this lesson, so make sure you've got one of those to hand as well. Now I'm going to point something out to you, and that is this equation sheet here. This is only part of it shown. There are 23 equations that you need to learn as part of your physics GCSE. Don't worry, we'll have plenty of time to practice them all, but you need to be able to remember them and then apply them. So this might be the first time you've come across these equations, although in year 8 you will have done some work on them, but I don't expect you will have been told that you have to learn them at that stage. Okay, so this is one of the equations that you need. And it's the work done equation. So if you find that recall sheet, that equation recall sheet, they should have been supplied with this lesson. Okay, and have a look down, and this is equation number 2. So the shorthand way of writing it is W equals Fs, which means W equals F times S. And on here we've got work done, that's the W, equals force times the distance. You also need to remember what they're measured in. So they're in shorthand here. J is for joules, N is for newtons, and M is for meters. Okay, so that's something to bear in mind. So we did meet this in year 8. Okay, so here's a few questions just to get you started. Okay, so have a look at that. All you've got to do when you get to question 2 and 3 is to use this equation. Okay, just a word of warning, remember to convert units if necessary. So this is to be in meters. Okay, pause the video and have a go. Okay, so here we are then. Let's see how you did. Just after a ball is thrown upwards, it has energy in its kinetic store because it's moving. And when the ball reaches the highest point, it has its biggest store of gravitational potential energy. Okay, now when a force of 50 meters moves a distance of 20 meters, how much work is done? Well, we multiply the force times the distance, so that's our 50 times our 20. Show me the working out, please. That's what I'd like to see. You can score your marks in the exam even if you make a mistake with the calculation in the end. Obviously there we get 1,000 joules. Now did you spot on question number 2 that you had to convert the 300 centimetres into metres first? So that's the first job you do, unit conversion. Okay, then write out the equation, substitute in the numbers you know. There's your force, 142 newtons, and there's your distance measured in meters. Multiply those together and we get 426 joules. Now you've probably forgotten what all this lesson is all about, so let's go back to this. Do you know who he is? Do you know what he does? And what does it have to do with today's lesson? Well, you might have spotted he was obviously London 2012. He's standing on the high board there. This is Tom Daly. He was a GB diver. 10-metre board was his speciality. He was a double world champion. These days he's a TV presenter and a vlogger too. Okay, so what's this lesson about? Is it to do with the streamlined shape he makes as he enters the water? Or is it to do with the store of gravitational potential energy he possesses at the top of the diving board? Okay, well it is actually the latter, and this is what we're going to do today. Okay, so down here for grades 4 and 5 we need to be able to calculate the gravitational potential energy store of a system. Okay, and I'll leave you to read the rest of that before we move on. So this is all to do with, well, roller coasters and things like that. It's a great topic, isn't it? So what's your favourite roller coaster? And on a roller coaster ride, where is the store of gravitational potential energy the highest? It's at the highest point up here, because if we look at the next slide, it shows us how we actually calculate gravitational potential energy. Now, lots of people might write GPE for short, but the official shorthand, the one I want you to use, is EP. That stands for energy, and that P stands for potential energy. Okay, now it's the energy stored in an object because of the height which it's lifted up to. So gravitational potential energy in joules, energy is always in joules, okay, equals mass times gravity times height. I say in class MGH. Gravitational potential energy is the MGH. Okay, so it's mass times gravity times height. Now, if you remember from year 8, mass times gravity gives us the weight in newtons. Okay, and on Earth, the gravitational field strength is 9.8 newtons per kilogram, but we often round this up to 10. You don't have to remember those numbers because if you need them in a question, they will be given to you in the question. Pause the video and write that down, please. It's a recall equation, so you need to learn that one. Okay, so how do we use it? Here's an example. Now, this is how I'd like you to write out equations from now on. Okay, let's read the question first of all. A weightlifter raises a bar of mass 70 kilograms to a height of 2.5 meters. Calculate the gravitational potential energy of the bar. Gravitational field strength is 10 newtons per kilogram. So this is the equation in symbols. Our gravitational potential energy EP equals our mass times our gravitational field strength times our height. Okay, so our height above the ground. So let's take the numbers, circle the numbers in the question if you like, and take them out of there and think where are they going. That's the mass, so that's the M. That's the height, so that's 2.5 meters is going into there, and our gravitational field strength is 10. So we put the numbers into the right place, and that, ladies and gentlemen, will score you quite a lot of marks in the exam. Okay, and then all you've got to do, get your calculator out, multiply it together, and don't forget the units. Okay, so coming back to this bit, make sure you've got written down the units that go with that equation. All right? Okay, now with this lesson, if you're doing it at home and you've got it from class charts, then you will find that there is an engager sheet with it. Okay, the whole thing looks like this. And you can calculate gravitational potential energy for 3 situations. And they are, I was going to say circled, but they're clouded here. Here you go. Okay, got this squiggly cloud around them. Okay, so for those 3, you have the right things to be able to work out gravitational potential energy. Okay, so let's use 10 for the gravitational field strength. That's 10 newtons per kilogram. And then in this example here, we've got a 20 kilogram child on top of a 300 meter tall building. Okay, so MGH. Right, so calculate the EP, gravitational potential energy, for those 3 using the MGH equation. Mass times gravity times height. Off you go. Okay, so there's some other questions here. Okay, what factors does the EP depend on and what is the equation? So that's just recall, write it back down. We can't do this bit here because this refers to another equation that we're going to meet next lesson. EK stands for kinetic energy. But you can answer this one. Which one has the most potential energy? Okay, so we're looking at which has the most gravitational potential energy. So we're calculating that for the helicopter, for the man on the ladder, and the 20 kilogram child. So our helicopter, we've got 3,000 kilograms times 10, which is our gravitational potential energy, times 20. So that gives us 600,000 joules. Our man on the ladder, we've got 80 kilograms times 10 times 60. So that gives us 48,000 joules. And for the child, we've got 20 kilograms times 10 times 300, which means that we've got 60,000 joules. So the helicopter is the one that gives us the most gravitational potential energy. Okay, now moving on, we're going to look at how we would rearrange the gravitational potential energy formula. Now this can be done 2 ways. I'm just going to explain one method today. This is just an easy method called the formula triangle. Now you have to pop your equation into the formula triangle and it only goes one way. This line across the middle means a dividing line. So when we go back to a look at our equation looked like this. Gravitational potential energy is mass times gravity times height. If we're going to use the formula triangle method, what I say to students is that this part of the equation is the biggest part because it's got 3 things multiplied together. More things multiplied together takes up more space. Okay, so if we go to our formula triangle, we'll put that on the bottom where there's more space. So M times G times H. So we're saying EP equals M times G times H. Now if I want to work out the mass, for example, I would use my finger and cover up the M like I'm covering it up with the cursor now, and I'm left with EP divided by gravity times height, gravitational field strength times height, G times H. Okay, so if I wanted to calculate height, I would do exactly the same thing. I would cover up the H, and I would be left with EP divided by mass times gravity. Pop those two in in brackets, okay, to make it work. All right, now I'll go through that again soon. All right, perhaps in another video, and explain it in a little bit more detail. Okay, so that's how we would manipulate the equation to get what we want to find out on its own. Now, there are some practice questions. So there's some foundation practice questions and some foundation to higher practice questions, followed by one of these recall equation sheets. And we have 23 of these. Okay, so you can always practice those as well. Okay, that goes from foundation to higher. So they start off easy, writing down the question, and then you've got some straightforward calculations to try, and then you have to rearrange the equation, and there might be different units to throw you off in there. So if I was you, I'd play the rest of the video, and then I would go back and do those calculation sheets towards the end. Okay? All right, so here's the foundation question. A lift in a building goes up 14 metres. Total mass of the people in the lift is 280 kilograms. Now this time it's told us that our gravitational field strength is 9.8 newtons per kilogram, so that's the value we're going to use. Calculate the increase in gravitational potential energy of the people in the lift. Give your answer to two significant figures. Now, if you don't do this last part, you can still score 2 out of the 3 marks so long as you show your workings. So pause the video, have a go, and then we'll have a look through it. Okay, so here we go. Write out your workings. Our EP is our MGH, remember, Mugaha, 280 kilograms times 9.8 times 14, because that's the height there. So our answer, 38,416 joules, but the job's not done yet because we've still got to write it to 2 significant figures. So the first 2 numbers, okay, we can use those because they're not zeros, so we use those, and then we only wanted 2 significant figures, so we set everything else to 0. Okay, and that answer scores us 3 marks. All right, have a look at this question here. Don't get caught out by the values for height. Read the question carefully and have a go at it. Okay, so the first mark is for writing down the equation. So it's a recall equation question, you see, so you're going to have to remember those. So EP equals M times G times H. And there we go. You can write it out in words, or you can write it out in symbols. Either is acceptable. And then it did say calculate the change in gravitational potential energy from the position where the student jumps to 20 metres below. So it's from there to 20 metres below. Maybe some of you got caught out and went for the whole 55 metres there, but it didn't say to the lowest point. Okay, so there's our mass of the student, 50 kilograms, gravitational field strength 9.8, and 20 metres because that's what they told us it was going to there. Okay, all right, plenary question. So we've got to do a comparison question between Tom and Paul. Okay, so read the question carefully, have a go at the answers, and we'll come back to it in just a second. Okay, so here's Tom's values. So he had a mass of 75. Okay, G is 10 in this question, and he was on the 3 metre board. Okay, so that gives us the answer there of 2,250 joules. Paul, on the other hand, was 120 kilograms, and he was only on the 1.5 metre board, and G is still N. Gravitational field strength is still N. So we get 120 times 10 times 1.5 equals 1,800 joules. And then the last question was, I hope you didn't miss that one over here, how much bigger is Tom's gravitational potential energy? So we'll just take the 2 values away from each other, and Tom's is 450 joules more. Okay, great, that takes us to the end of the lesson. Let's see where you got to. Now you can have a go and have a go at those question sheets. Okay, all right, see you next time.